Hi, I'm Sarah Boltman from Butterfly Data. We have a talented and diverse team at Butterfly Data, but we added to that team by inviting Peter Carrasco to join us. One thing that I think makes Butterfly Data unique is our experience of working with social media data. In this case, it was a lot more interesting to look at the tweets in Spain as the pandemic unfolded, to see what kind of things people were talking about. The lockdown was particularly hard, and were people protesting about that? Many places there were school closures and increased social distancing measures. Butterfly Data has been a SaaS partner for many years. I've been using SaaS myself since 2003, and it's still my go-to tool for doing that initial data exploration and data cleaning when you need to be able to join different data sources together. This challenge has provided anonymised real-world data about thousands of COVID patients. It's been made available to us purely for the purposes of this hackathon. But I think that this is a fantastic first step in sharing data across Europe and across institutions to help data scientists to understand the trends and the patterns within the data, and perhaps even influence what decisions are made about treatment. I know it sounds brutal, but in a situation where your healthcare system is overwhelmed and you only have enough oxygen or ventilators for a certain number of people, using real-world patient data to risk stratify patient groups, whether that's by demographics, by comorbidities, by their current vital signs, is absolutely vital to prioritise treatment. If the healthcare system is overwhelmed, the sad fact is there may not be enough hospital beds, enough ventilators, or enough oxygen for everyone. And it's as well to be able to triage those patients so that you get the best overall outcome. In the early days of the pandemic, SAS produced a COVID-19 dashboard using visual analytics, showing how the pandemic had unfolded across the world, from its beginnings in Wuhan in China, as it spread through Italy and Europe. Spain was particularly badly affected. We can see, as the time slider moves to the right, as we move through April and May, different parts of Spain experienced an increasing number of COVID cases and sadly COVID deaths. The dataset that we've been given covers the period from April 2020 to November 2020. Our first task was to get to grips with the data we were seeing. We have patient admission times, vital signs such as heart rate, temperature, oxygen saturation. We have information about whether or not the patient was admitted to the ICU or not, and how long they spent there, what medication they were given, and what their final diagnosis was. Combining all this data together in SAS, we've been able to produce a dashboard and a predictive model so that we can take data from the patient when they're admitted and predict whether or not they're likely to subsequently be moved to the intensive care unit and whether or not their case is likely to worsen. We've attempted to predict which patients are likely to stay in hospital for more than 5 days and which patients are likely to die.
So throughout our initial discovery, we wanted to know the spread of ages of all the patients for which we had data. And on top of that, the proportion of males to females across those same ages. We've got a bar chart here with, on the y-axis, the frequency of those patients across each age, and across the x-axis, all of those ages. You can see the letters H and M, and they refer to hombres and mujeres. So subsequent discovery of the data. This is a representation of each individual across the 6 tests. What's nice about this visualization here is that you can see quite clearly when the data was collected. So we've got a high proportion of individuals admitted for the duration between March and June of 2020. We've got very few people throughout July. And we can see blood sugar levels here, O2 saturation, heart rate, systolic pressure and diastolic pressure. Obviously, the blood pressures that are normally found in the same result there. I've also created some button bars on this dashboard. So in particular, I wanted to be able to split up the ages according to categories. So not individual ages, but I've split them up 0 to 18, 18 to 30, 30 to 45, and so on. And what I've also got in the top left is a split between those individuals that have been discharged for successful reasons Maybe that was voluntary, but otherwise they walked out of the hospital and otherwise deceased. So if we now look at short versus long term, with initially the spread of patients across their relative number of days they spent in hospital. Some people were admitted and discharged within 3 or 4 days. We've got data on individuals that stayed up to 131 days in hospital. On the left here is a term split. This allows the user to suggest the time or the relative number of days in hospital up to which a person can be recorded as a short-term patient as opposed to a long-term patient. In the line chart at the bottom, I am showing median value of the result from that specific test. So the tests are again, there you can scroll through the tests at the bottom of the page. And it's showing the difference between a short-term patient and a long-term patient, just for those first 2 days. And ultimately, we would like to be in a position where we can gather insights from the first 2 days of anyone's stay in hospital or use in a prediction as to whether they will be a short or a long-term patient going forward, and other things in turn.
The concept of this use case is to offer a program that can inform clinical staff if the patient's early hospital data suggests they are likely to be a short or long stay patient. The data we're using is from March to November 2020. Since then, COVID patient care and medication has changed. If an up-to-date database is used, we could give a more accurate assessment of whether the patient is likely to be a short or long stay patient.